All right, so today we're going to show you guys how to set up a BCA chart for a homework problem. The homework problems are on the worksheet number 2 that you have for homework tonight. The equation for number 1 is N2 plus 3H2 will produce 2 ammonias. Okay? The problem tells you that you have 7 moles of nitrogen and you have 5 moles of hydrogen. Since the reaction has not occurred yet, you have 0 product. Everybody cool with me so far? Okay, so now what we're going to do is we're going to see how many batches we can make with what we have, with our inventory. For every batch of nitrogen, I need 1 mole of nitrogen. I have 7. So how many batches could I make with 7 moles of nitrogen? I could make 7. For every batch, I need 3 moles of hydrogen. I have 5. How many batches could we make? It's actually a decimal here. This is 1.67. Does that make sense? And when you're doing something like a cheeseburger, we can't do that. In this, we can because we're talking about a mole. If you remember how big a mole is, there's 6.02, and you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. All these zeros here tell me that a decimal is really not that big a deal here. But if I'm making a cheeseburger, a decimal of cheese is a big deal. Does that make sense? All right, so since 1.67 is the lowest number of batches that we can make, this is the one that we have to use for our calculations. Because once this one runs out, I can't make any more. So 1.67 times 1 is minus 1.67. We know this one is going to be the 5 minus the 5. What is 1.67 times 2? Because now we're on the right side of the arrow. We're doing our products. We're going to add this. So we're going to have a 4 here, a 3 here. That makes 3.34. So now we have our change line is complete. Now we need to find out what is our after. We started with 7. What is 7 minus 1.67? 5.33. We started with 5. We used 5. What's left? 0. We started with 0. We made 3.34. What do we have? 3.34. This is the answer they're asking for. Okay? This one ran out. What do we call the one that ran out? This is our limiting reagent or reactant. And this one, I still have some left. What do we call that? This is our excess. Everybody cool with that? Now, here's the problem with doing this one with the equations that I showed you guys earlier for stoichiometry. Unless you know which one is the limiting reagent, you would have to set up 2 sets of equations with each reactant with the product to see which one produced the least amount.
Why does it matter which is the limiting reagent?
Because the limiting reagent limits how much we can actually make. So you only can produce as much as the limiting reagent would. So I would start out, if I saw this problem and I was doing it without the BCA chart, I would start with the 7 and I'd find out that I'd made some gargantuan number over here. It'd be 14 moles. I'm not making 14 moles, am I? So once I got through the 7, then I would have to use the 5. I'd find out that I only made 3.34 moles. That's the actual amount because it's the lower amount. Does that make sense to everybody? Does anybody have any questions on this BCA chart? Everybody have the idea of how to put a BCA chart together for each one of these problems?
Sure.
Okay, that's your homework for tonight then.